We performed this lab to better understand how to construct and interpret the slopes of various graphs of motion. One thing that I learned from this lab is that objects will pick up speed over time. I also learned how to find acceleration by using the equation a equals 2d over t squared. Give two ways you could tell from the data table and or the graphs that you were dealing with a constant velocity from part 1 of this lab experiment. I could tell that I was dealing with constant velocity on part 1 of this experiment because on the graphs I could tell that there was a constant slope that was being formed and it was consistently the same on the graphs. Also, there was a constant velocity. I could also tell there was a constant velocity because the table told me that the numbers were steadily increasing at a similar rate every time. Question 2 asks, compare and contrast the distance versus time graph or data table from part 1 with the distance versus time graph or data table from part 2. What do they show that is similar? What do they show that is different? One thing that they show is similar is that on the tables, the speed of the object is steadily increasing over time. Another thing is that both graphs shows that they have a similar slope on their own individual graphs, and that they are both almost accelerating in a straight line going upwards this way. One thing that I saw that was different is that the tennis ball took a lot more time to accelerate than the car did. What I mean by that is that the car built up speed over time and the tennis ball stayed more of a constant speed over time. Question 3 asks, how does this lab relate to Chapter 2, linear motion material? This lab is related to Chapter 2 because a lot of the graphs show constant speed, acceleration, and deceleration. Also is related to Chapter 2 through the different types of time and speed graphs.